Hello everyone and welcome back to my YouTube channel. My name is Saksham and this is episode 4 of building threat detection lab from scratch. Today we'll be building another threat detection lab that will be based out of Elastic. In the last episode we built a detection lab that was based out of Splunk, a very bare bones setup where you had Splunk Analytics platform, Splunk Universal Forwarder that was connected to a Windows machine and was shipping sysmon data from that Windows machine back to our logging machine, right? As you can see on the screen, we have the architectures of both of these different setups laid down. So in the last, as I mentioned in the last video, we built this. Um, in this video, we'll try to build this complex setup. But one of the questions that you might have is why build another setup when you already have Splunk based detection lab up and running? There are mainly two reasons why we are building this setup. One of them is, let us not limit ourselves by one single platform and try to explore what other platforms have to offer. There are a lot of different capabilities that different platforms have to offer, and we as threat detection engineer or security engineer in defense should actually go and explore what products and platforms are available in the market and how do they actually support your analytics and different requirements, right? Another one and very key important requirement is we need to ship data and variety of data, right? Splunk free is actually limited by ingestion of only 500 MB per day, while Elastic based detection lab doesn't give you any such limitation, right? You're free to ingest an amount of data based on your hardware specs. So we wanted this setup so that we can ingest um, as large data set as we want and still be able to perform analytics and perform detections hunts over them and be not limited by anything such as ingestion limit, right? So based on these two reasons we'll actually start building another threat detection lab. But in the future we'll see how we can have same data source going into multiple of these different platforms so that you have same data available in different platforms and you can see how analytics can vary between two platforms, right? If you can write a elastic based query, how does it differ from a Splunk based query for the same data set for the same analytic requirement, right? So we'll quickly get started by building the elastic detection lab. Let's quickly jump back to the virtual machines that we created last time. If you have not reached this step where you have all these three virtual machines, a Windows victim box, a logging server, and a firewall, do watch the previous videos to reach this step where you have all of these three virtual machines up and running and configured, and then you can start building on top of it, right? So we'll quickly get started. We'll just go back to our logging server. Check for the running containers, and we don't have any. But if we see, we have the Splunk container still there that we created last time, and we'll let it be there. We'll just not run it. We'll later use this container to create a more complex Splunk and Elastic intertwined setup. Uh, but for now, we'll just clear this out and we'll go back to the browser. We will search for Elastic Container Project, GitHub. So this is a wonderful project that is given by one of the members of Elastic, and this project actually helps you run a containerized, an easy and quick way to run a containerized instance of Elasticsearch, Kibana, and Fleet Server with all SSL configured and almost all the security settings also configured. So instead of taking a more tedious route of configuring all the containers and all the solutions manually, we'll just run this project and get our containers up and running. So this will quickly help us set up the SIEM and the Fleet server, right? And that too all SSL enabled. So we'll quickly get this project up and running. Go to downloads. We'll just start by cloning the project. As you can see, we have a Docker Compose file which has all the configuration of the containers that it will spin up. So if you do cat Docker Compose YAML, you will see that it basically runs four different containers. One of the container is called setup. It's basically an Elasticsearch image, but what it does is it basically sets up all the certificates and then puts it into the volume mount so that the other containers such as Elasticsearch can actually consume those certificates from the volume mount, right? If you can see here the configurations, we have another container called Kibana and the fourth container as fleet server. So all of these four containers will be spinned up. So we'll just do clear, and if you do ls, we also get a elastic container.sh bash script that basically does the orchestration for all of this Docker spinning up. Basically, it's a wrapper that takes care of commands so that it's not too complex for anybody to get or dive into the project, right? So we'll just do dot slash elastic container.sh and we'll do start. So if you just run this bare bones, it will give you all the different commands that it supports, right? So you see, we can use start, stage, stop, destroy, restart, status, all of these. So we'll just use the start command to create a container network and start containers, right? So we'll just do docker, or we'll do dot slash elastic container start. Okay, it says that we have not changed the default values, right? So we'll just go and change the default values in a environment variable file. So if you do ls, you cannot see a .env file, but if you can do ls hyphen a, you see there's a hidden .env file. So what we'll do is we'll just vim .env to edit it. We don't have vim, so let's do sudo apt install vim. Vim.env. So this is the local URL. What we'll do is we'll change these configuration, and I'll change these IPs to 0.0.0.0, which means this should be working on any network interface that is attached to this machine. So even if I do localhost or the bridged IP, the application should be available on all of them, right? So if I do 0.0, it means exposed to all the network interfaces. I'll just change this password to the lab default. We'll be using 8.14, and the memory limit, as you can see, is 2 GB for Elastic and 2 GB for Kibana that it will use. We'll leave it as default. We'll save the configuration and we'll try running this now. And we'll let it pull all the images and run those containers. Okay, so it has completed all the pull and now it is running all of those containers. It has created the network. It has created three volumes, right? Elastic Container Kibana data, Elastic Container certs, Elastic Container ES data 01. And now it has actually spinned up container ECP Elasticsearch security setup, which is in healthy state, and it is waiting for ECP Elasticsearch to come up. We'll just give it a few minutes to load. Okay, our Elasticsearch container became healthy. Okay, all of our containers are up and healthy. So it has now started configuring them. It is now installing the pre-packaged rules, out of the box rules that are part of Elastic Security stack. So meanwhile this is happening, if you do a new tab and you do docker ps, you should see all of these three containers running: Fleet Server, Kibana, and Elasticsearch. There are almost 1,000 rules as part of this, so it will take some time. And if you also see the status of Kibana and Elasticsearch is healthy here. We'll just wait this to complete. Okay, it is now setting up Fleet. The Fleet server is also basically an Elastic agent just running in a management mode. So it is also to be integrated and configured. So that is the configuration it is doing right now, enrolling the fleet to the Elasticsearch. Okay, so the process has completed and it has given us the URL, the username, and the password. So we'll just go and check. You can do HTTPS since SSL is already configured as part of this. Our IP, or we can do localhost, and we'll type in the IP of our Kibana. It will give you this error. We'll click on advanced. We'll accept the risk and continue. Since this is our self-signed certificates, they are not trusted. The username should be Elastic and the password should be whatever we configured. I'll just copy paste the password from here. And you see our Elastic stack is up and running. And this is by far the easiest way to get your Elastic stack set up. You can also follow the binary installation method, but running containers and getting it up and running and everything configured, as you can see, if you go to Fleet, we also have a Fleet server that is already configured in healthy state and reporting, right? This is by far the easiest way to get all of these three components up and running, integrated, and all the security settings and everything populated with SSL, right? So I highly recommend you take this route rather than going and setting up all the binaries one by one. And this is the latest 8.14 version, so we also get a lot of different features, such as we get ESQL language that is all generally available right now. uh, so what we'll do is we'll now go back to the architecture diagram that we created. We already have the stack running, right? If you see on the right side of the curly braces, we have Elastic Agent, Elasticsearch, Fleet Integration Server, Kibana. Elastic Agent is still missing, but these three components are up and running in form of containers. So we'll now set up the right hand side and then we'll just integrate via Elastic Agent, right? So we'll go to the fleet and we'll go to settings and we'll see the IP and everything is already configured, right? This means that the IP that we have should be same, right? Yeah, 1.16 is the IP of the logging server, and all of that IPs are configured here for outputs. And Fleet server running on the default port of 8220. So we are good here. Let's go back to our agent and we'll create a new agent policy. We'll say EDR, or we'll say Windows logging, and put all the logging methodologies or integrations in this one. Select Windows logging and we'll click on add integration. We'll add Elastic Defend, which is one of the best free EDR available in the market right now for you to play along and play with it and explore the data and everything. We'll just add Elastic Defend. We'll select complete EDR and we'll click save and continue. Okay, we'll add another integration that will be for Windows. We'll use this integration to collect Windows logs from the setup. So we'll just name it Windows 1, partial operational, sysmon operational. We don't want services and metrics, so we'll turn this off. We'll click save and continue. So now what we have is basically a policy that has Windows, event collection, and EDR on it. So we'll go back and get an agent installed with this policy. What we need is basically uh, the command to be running on the Windows machine. So if we go to this, select Windows logging, we'll be running in the enrollment managed mode. We'll select Windows, and this is the partial command that we need to run to get the agent reporting here. It is listening for an agent. So what we'll do is we cannot since directly copy paste from VM to VM. We'll just go to our Windows machine. Since we had the allow rule on firewall, our Elastic tenant should also be, or Elastic console should also be accessible from here. Let's just go to our IP 1.16.5601. It is HTTPS. Yep. So we are able to log into Elastic. Okay, we'll go to same fleet, add agent, select the policy that we want to apply. We will select Windows logging. We have Windows and Elastic Defend on it. Managed mode, Windows. We'll copy this URL and we'll go to partial and run as administrator. Okay, let's go to CD downloads. Okay, we'll run this command in this location. But before running, let's paste the commands here. And I'll do ---- insecure. This flag actually lets you uh, move data to the Elastic console without having the TLS setup on every node. Since this is a detection lab, uh, it's okay if we just spare that TLS configuration. We'll let it run. It will take a few minutes because it will download the binary, then expand the archive, and then run the command from inside it. So let it run. So it will give you this prompt. We'll say yes, and it will start installing, copying the files. If we move this, It says it has successfully installed. So we'll just go here and say one agent has been enrolled. Okay, view enrolled agents. It says updating. We'll give it a few seconds to load. Okay, it is healthy. Let's do this in logging server. I think we'll have a better view in logging server. Yep. Let's go to discover logs, and we do have some logs. We'll just say event.dataset as a field. Okay, elastic endpoint security logs are coming. Event.action. So if you can see now, um, we have registry events modification. So let me just show you what all events are coming. If we just click on event dataset, you see sysmon, file, registry, server, network, metric beat, file beat, all of these library events, all of these events that are part of Windows and Elastic Defend EDR have started coming to our Elastic Stack or the SIEM. If I could just refresh, uh, you see in last 1 minute we are still getting new logs. So the logs are real time and they are ingested. So if we go back to our architecture, we have an Elastic agent setup, which is the log shipper on Windows. We have ElasticSearch, Kibana SIEM module, Fleet integration server, EDR, and Sysmon setup. Windows native logging also. What we need is Osquery and Packetbeat. So what we'll do is, since you have already installed agent, it's now very easy to manage it from Fleet, right? So we go to Fleet. We select the agent policy which we want to alter. We click on add integration and we instruct it to collect a different log as well. So we say um, do packet beat, right? Packet network packet capture. So if we click on this, it's basically an integration version of packet beat. So you see all of these data or these network protocol captures will start happening. So we'll click on this. Network traffic, existing host, save and continue, save and deploy changes. Now this will deploy the change and add this integration to the agent. We'll let this happen. As you can see, the network traffic integration is now part of the Windows policy, Windows logging policy. We go back. Let's go to agent. Agent is healthy 7 seconds ago. Okay, spawned a PID. Looks good. There's no error reported. So if we go back to discover, there should be a separate index that we could, or data stream that we should see, that is logs network traffic. We go to data view and let's do event.action as a field. Okay, so we do get network flow. We can expand one of them. We understand the IP addresses and network information is actually captured. So this denotes that we are getting the flow data as well via packet beat. So we have got the EDR and the packet beat setup with Windows native logging and Sysmon. Let's add the last component, that is Osquery. Let's click on Osquery, click on add Osquery, and we'll save and continue. Okay, so now we have all of those 4 important integrations done. Let's see the status of Fleet. 6 seconds ago healthy. Osquery also works fine. See no issue. Let's go to Osquery Manager. Okay, add this integration. Okay, I think we already added Osquery Manager. It is still not reflecting. Osquery Manager. Okay, we did not add Osquery Manager and we installed Osquery Logs. Those are two different integrations. Osquery Logs allow you to pull Osquery search logs, result logs, basically from the endpoint, while Osquery Manager allows you to run queries and manage it from Elastic. So either way, let's install both of them, and let's go to Osquery. Okay, we can run a new live query. Let's select the agent that we want to run on. Let's do a sample query. Select start from processes. This should work. Let's submit it. Okay, one agent has responded. That means agent is receiving queries from here. So his query manager is working as expected, and we get a list or a table of all the command lines. So if we go back to the architecture diagram, we have Osquery, EDR, SIEM, Packetbeat, and Windows native logging all configured. And this marks this threat detection lab based out of Elastic as complete, right? Because we have all the integrations now, everything is working as expected, and you can use this lab now to conduct more threat simulations or observe, detonate threats and observe their telemetry, or maybe ingest custom telemetry to this. And this is a full-fledged working threat lab. um, I'll just wrap this video here. In the next video, we'll start setting up a custom pipeline and possibly ship all of these logs via Elastic Agent to a different pipeline log manager or a pipeline management solution. And from there, we'll stream data to different platforms. Basically, we'll be creating a more complex lab environment. So stay tuned. I hope this video was helpful and beneficial as well. I hope to see you in the next video. And do like and subscribe and share this video if you think this video will be helpful for other folks as well. Thank you so much.